So you still may be wondering, well, why? Why do we need to do this? And so this has to do with how memory is allocated. When you create an integer variable like this is called static allocation. So the memory is saved during compile time because the compiler knows, well, an integer variable will take 32 bits. So it's saving that space for the program. It knows how much space that's going to take up. But when we borrow memory from the heap, that's called dynamic allocation. And that happens at runtime when you're running your program. So the compiler knows you will be needing an integer. It won't actually go allocate that memory until runtime. So that's the difference between static allocation and dynamic allocation, which you're probably still wondering why. Well, it has to do with arrays. Let's say we want to create an array at runtime. So we are going to create a variable sales and assign it 0. And then we want to cout enter number of sales and read that into sales. And then I want to create an integer array of that size. So most people would think, well, let's just go ahead and create the sales numbers array with sales. Okay, this won't work. This is not compliant because at compile time, we don't know how big sales is going to be. So the compiler doesn't know how many integers it needs to save when this program is running. So this doesn't work, okay, because it's you can't create an unknown array size at runtime. But what we can do is I can create an integer pointer called sales numbers pointer. And then after they enter the sales, I can then borrow that much memory on the heap. So I can say sales number pointer is assigned, and then using the new, and then I'm going to create an integer array of size sales. Okay, so when I run my program, it's going to say enter the number of sales. I'll say 10, and it created that size of an array on the heap. And then when I'm done with my program, I want to deallocate that memory, right? I want to give it back to the heap. So I'm going to say delete an array cells number pointer. So that's going to just deallocate the memory. Remember, it's not going to delete the pointer. It's just going to say, okay, I'm done using that memory. And then we will set that back to 0 so that our variable is not holding the address any longer.